Before we jump into working with perpendicular lines, let's just quickly look at this investigation. I forgot to show you this with the parallel lines with the previous video, but let's just quickly look at that now. So on the Cartesian plane there, we've got our straight line. Y is equal to 2x plus 3. My y-intercept is 3, and we can see that there. And our gradient is equal to, 2. I can read it off there. That might be a little bit small for you, but I can also see that I made my gradient there too. Okay, great. So there is that line. Now, what did I indicate over there? That is just the gradient that I'm showing. So there my gradient would be 1, 2, which is my vertical change, my change in my two y values if I'm using that point over there, and if I'm using that point over there. So it would be 2 over 1, and that's where we get the gradient of 2. Would it be different if I were to get the gradient between that point over there and that point over there? No, it's going to be exactly the same. It's going to be 1, 2, 3, 4 over 1, 2, which is still just 2. Remember, your straight line has a constant gradient. Okay, perfect. Let's look at parallel lines. In the previous video, we said that parallel lines have the same gradient. So let's put in a parallel line there. So we can see there in the equation that's given that it's got the same gradient. We can see that. But as we move this around, look there. I mean, these lines they have exactly the same slope. The distance between them stays constant. They have the same steepness. If I put this gradient in there, so if I'm using that point there and that point there, let's work out the gradient. 1, 2, 3, 4 over 1, 2, which is just 4 divided by 2. It is a gradient of 2. Let's look at the perpendicular one. This is one that takes a little bit longer to get used to, I find, for students. I am going to change that line up a little bit. Let's make the gradient, let's make it 3. Let's see how that works. So there is our straight line with a y-intercept of, let's make the y-intercept by 1. And our gradient is 3. How do we get to 3? Well, if I use that point and that point there, it would be 1, 2, 3, 4, 5, 6. Gives me the change in my two y values over 1, 2. So 6 divided by 2, it would give me my gradient of 3 there that we can see. I changed it, sorry. And there is my gradient of 3 that we can read off there, or we can see it there. Okay, perfect. Let's put in a perpendicular line. There is our perpendicular line, meaning that there would be a 90-degree angle where they cut or intersect. Let's see what the gradient of the perpendicular line will be. There is our perpendicular line. Let's work out the gradient. Well, the direction of the gradient, we know that that is a decreasing line. It will have a negative gradient. If I count my blocks, in this case, I won't be able to count my blocks that easily. I'm going to change to this one a little bit, just that we can count the blocks for now. So if this line has a gradient of 2, it's got a gradient of 2, and I mean we can count the blocks. But let's see what the gradient of the line is then that is perpendicular to that line. So our change in y, if I use that point and that point, would be 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8. So 4 divided by 8 will give us a half, but this is a negative direction. So this slope would be negative a half. So we need to try and find a relationship there between the one line has a gradient of 2 and the line perpendicular to it has a gradient of negative, so the opposite sign, and then 1 over 2. Let's explore another one. Let's see if we can start spotting a pattern. So let me just take the perpendicular line and its slope away. So there we've got a line. It cuts by y, by 2. It cuts the y-axis by 2, and our gradient is just 1. And there we can see that. Let's put in the perpendicular line. It will be somewhere there. It could also be there. I mean, it could also form the 90-degree angle there. Does it really matter? Let's put in that slope. So if I put that slope in there, that's a big one. I chose that point and that point. Let's see what that slope is. Well, from there, 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6, 7, 8. 8 over 8 gives me a gradient of 1 with a positive direction. So this line has got a gradient of positive 1, and this gradient has a line of negative 1. So I think what we can already tell is the one line will have a positive gradient and the other one will have a negative gradient. Let's make another change. Let's move this down a bit. Let's move it down there, and let's make this gradient 2. Okay, there is our original line. There is our gradient of 2. Let's put in the perpendicular line. Oh no, we had a gradient of 2 with the previous example, didn't we? So let's just do that a little bit differently. Okay, so there we've got a gradient of 3. We can see that. Let's put in the perpendicular line. There it is. Let's explore its gradient. We can predict that it will be a negative gradient. There is the negative gradient, and I can't go count the blocks because I keep making terrible choices, and it is hidden from us over there. It is negative 0,333, which should be 1 over 3. So this gradient would be 1 over 3. So let's find that relationship. If my gradient of the one line is positive 3, the gradient of my perpendicular line will be negative 1 over 3. So we get the reciprocal. Let's make this gradient 4. This line will have a gradient of 4. The line perpendicular to it will have a gradient of negative 1 over 1, 2, 3, 4. So you take the gradient of your original line, and to get the gradient of the line that is perpendicular to it, we're going to change the sign, and we will then flip it, which would be 1 over 4. And that is the pattern that we've seen that works every single time. Now let's see how we can use this and what sort of formula can we derive from that we can use that in our sums where we have to find the equation of lines. Let's just quickly summarize what we saw in this, let's call it a demonstration. When lines are perpendicular, we saw that if the gradient of this one is, let's say, negative a quarter, then the gradient of this one will be equal to opposite sign positive, and we flip it around, 4. And let's just write down another one. If we had these perpendicular lines, if the gradient of this one is equal to positive 2, then the gradient of this one will be negative 1 over 2 if the lines are perpendicular. So let's see with the first one, if we take negative a half, no, that's not a half, that's a quarter, negative a quarter, and I times that by 4, what would that give us? Well, we could just put the 4 over 1 there, and if we multiply them, it would give us negative 4 over 4, which is just equal to negative 1. If we take the second example, if we take negative a half and we multiply that by 2, what would that give us? Well, that's just 2 over 1. If we multiply that, it would give us negative 2 over 2, and that would be equal to negative 1. And that is going to happen every single time. And that is where our rule comes from that we use for lines that are perpendicular. If you take the gradient of the one, like we did there, and you multiply it by the gradient of the other, there it is. If it lands up giving you negative 1, then the lines must be perpendicular. Okay, now let's see how we can use that. We're going to do 3 different questions. Let's see. First question. It says, state whether the following lines are parallel, perpendicular, or neither. Let's look at A. We've got 2 straight lines. We've got this one is in its standard form. And, the other one is also in its standard form. So I don't really have to write them over. Let's just work with what we've got over there. Well, what do we need to look at? We need to look at the gradients to comment on this. Because if the gradients are the same, we know that they are parallel. If we multiply the 2 gradients and they give us -1 or -1, then we know that the lines are perpendicular. But if if neither of those 2 things is true, then it's neither. The lines are not parallel nor perpendicular. I don't know if my fancy English worked there, but you know what I mean. So let's test it out. We've got a gradient of 3 there for the one line. And then we've got a gradient of -3 there. So the gradients are not the same. So this one is definitely not parallel. Let's see if we multiply them, if they will give us -1. Maybe you already checked that. So if you take -3 and you multiply it by 3, it gives you -9. It definitely doesn't give you -1. So it's also not perpendicular, so it must be neither. Those two lines, if we were to draw them on the Cartesian plane, they're not going to be parallel, and it's also not going to be perpendicular lines. Let's look at B. Are they in standard form? No, we can write that first one in standard form by dividing by 2, and then dividing the other side by 2 as well, and dividing that by 2. Do you see what I did there? I just took that and I just wrote it in standard form, and I just changed the position by moving that one to the front, that it is in standard form. And then the other equation that we're looking for is that. What must we do again? We must comment on whether it's parallel, perpendicular, or neither. Let's look at the gradients, because the gradient is what will tell us that. The gradient of the one line is 4, and the gradient of the other line is 4 as well. The gradients are the same, so look no further. We know that these would be parallel. Cheapers. Parallel. Ooh, sorry. Okay, so B would be parallel. The first one, I feel like my organization there is not great. So let me just fix that. This one was neither. The second pair of lines are parallel. Let's look at C. With C, I also first have to write both of them in standard form. So for the first one, if I write this one, let's just quickly deal with those equations. If I put that in standard form, I'm going to divide by a -3 everywhere. And let's see what happens. That would give me -2/3x. And this one would give me negative, and a negative would give me that +1. I do feel the need to just quickly show this one on the side there. So if we've got 2x that it's being divided by a -3, remember, like what I said when we were dealing with, it was in the standard form video, so go check that out if you missed that. In order to make it clear what is the gradient, we just go write that, no, not like that, we go write that one like 2/3, and don't forget the negative. It's a negative gradient and then x, because then we can clearly see when we write it like that what the gradient is. So it means the same thing. We're not changing to the sun. We're just writing it slightly differently that we can clearly see what the gradient is. And now you might be asking and say, okay, but the negative sign is there. It doesn't really matter. The whole fraction is negative. Whether you've got -1/2, it's the same as saying 1/-2 is the same as saying -1/2. It is a negative fraction. Okay, where was I? I've kind of lost what I'm supposed to do there. I wrote the first one in standard form. There it is. We also have to write the second one in standard form. So this one, y + 4 is equal to 3x/2. And let's write it in standard form. I'm just going to take that one over. And again, I'm just going to write that one that I can clearly see what the gradient is. So it is 3/2x, and then take 4 away. There I have the second line in standard form. Now, what are we supposed to do? We are supposed to comment on whether it's parallel, perpendicular, or neither. If I look at the two gradients, let's just flag them or highlight them. There's my gradient of the one line and my gradient of the other line. They are not the same, so we are ruling out parallel. We need to check if they're perpendicular. While they've got opposite signs, which is looking good, let's see what happens if we multiply them. -2/3, and we multiply it by 3/2. That would give us -6/6, and that is -1. If that happens, if we multiply the two gradients and they give us -1, we know that it means these lines are perpendicular. So the third one, they are perpendicular. perpendicular. Question 2. Determine the equation of the line. Determine equation of the line already tells us that it is a line and it will be in this standard form. It passes through that point. So if it passes through that point, we know that we can substitute that point in if we need to or want to, which is perpendicular. Very important. What do we know about our perpendicular lines? We know something about their gradient. We know that the gradient of the one line times the gradient of the other line will always give us -1. To the line with the equation of that. Okay, so now I just need to read it again and just put everything together because I was just looking at that in bits and pieces. That one is in standard form. So it says, determine the equation of the line. So we need to find the equation of the line that goes through that point, and it is perpendicular to that line. Okay, perfect. So there's a line that we need to find. It is perpendicular to this line, which is in standard form. Y is equal to 3x plus 5. And the only thing they gave us is that our line goes through this point of 3 and -1. It's always a good idea to go just make a visual for yourself that we can make sense of it. So we can't go straight to our line that we're supposed to find because we don't have enough information there. We only have one point on that line. So we are going to rely on some of the information from the other line, which is good. So the moment that you see your 90-degree angle, your perpendicular, you need to know that that is important and that we can use that. Why? Because there's something about the gradient. So this one is in standard form, and we already know what its gradient is. The gradient of this line is 3. So we can use that to get the gradient of our line. So gradient of 3, it means that the gradient of the line that we've got the gradient of times our line with the missing gradient will give us -1. Why? Because the lines are perpendicular. So let's substitute that in. Let's substitute that one is equal to 3. And then we're going to times it by our gradient that I'm just going to say is m is equal to -1. So I am going to divide by 3 on this side. It's an equation that we're solving. So I'm going to divide that side by 3. Then I've got my m by itself, but then I have to do the same on the other side. So therefore, the gradient of our line is equal to -1/3. You could have also used the shortcut, grade 9s. Lots of people like that, lots of people don't. What is the shortcut? If the gradient of the one line is 3, the gradient of the other line must be the opposite sign. So that one is +3. So our perpendicular line's gradient will be the opposite sign, and then we flip it. If it was 3/1, like over there, we can just write that as a fraction as 3/1, right? And then we just flip it. And there we get the same. It gives us exactly the same answer. I also just wanted to show you the equation bit of how that works. So now we already know that our line has a gradient of -1/3, and we just don't know the y-intercept yet. We don't know the c-value, but they did give us another point that is on our line, so we can go substitute that in. We're going to sub in the point 3 and -1. So in the place of my y, I am going to plug in the -1 because in that point, that is my x, right? And that is my y. So in the place of my y is -1. In the place of my x is a 3 and plus c. All right, now let's solve that. I'm just going to carry on over there. So now we just have an equation that we need to solve, where c is the missing variable that we're trying to find. So I've got -1 is equal to, let's just deal with that situation of what is going on over there. So that just means that it is -1/3 that is being multiplied by, I'm just going to write it as 3/1 because then both are fractions, and then plus c. And I mean, most of you just put that into your calculator from the get-go, which is perfectly fine. And that would give us -3/3, which is just -1 plus c. We want c by itself. So in order to get that by itself, I'm going to say +1 on the right-hand side because then they cancel out as long as I do it on the other side. So what we're left with is a c on the right-hand side and a 0 on the left-hand side. So our c value is 0. So our line's equation is y is equal to negative 1 over 3x plus our y-intercept of 0. So we don't have to write that one down. Third and last question. Given that A is over there, okay, so they gave us where A is, but they didn't indicate A on the diagram. So I'm just going to go put that in there. A is 0 and 3. And then they gave us B. B has that coordinate. Okay, we can see where B is, but they didn't put the coordinate on there. So I'm going to put that as negative 4 and negative 3. You don't have to do that if you don't want to. Then it says that we need to determine the equation of f of x. There's more than one graph on the Cartesian plane, so we just use that notation to distinguish between the two graphs, but we know that that is just another notation for referring to y. Determine the equation of f of x if the lines are perpendicular. Immediately then you need to think about gradients. Gradients of the one times the gradient of the other will give you -1, and we can also use the shortcut. Okay, so that is crucial information. Let's just read it again from the beginning. Given that you've got point A and point B, determine the equation of f of x if the lines are perpendicular. Okay, we can do that. Let's go look at f. F is our orange line there. Ooh, cheapers. We've got given absolutely nothing there. The only information that we were given there that's obviously really important is that the lines are perpendicular. Okay, so I'm just going to indicate that there. So we're going to have to rely on the purple line, on g of x, to get some information about f of x. Really good is that they share that point, which is the x-intercept for both of them. That is really important, I'm sure. Okay, what do we need? Well, if we can get the gradient of g of x, that can help us find the gradient of f of x. So let's do that first. Let's go calculate the gradient of g of x. So that would be -3 take away 3, -4 take away 0. That would be -6 over -4, and that will give us positive 3 over 2. 3 over 2. There is the gradient for g. That is the gradient for g. Is 3 over 2, which is also 1.5. Okay, now we've got that gradient, so we know that therefore the gradient of our line that we're looking for of f will be opposite sign, and we flip it around. I'm just using the shortcut for this one. You can also go plug it into our little formula there, and you will see that you get the same answer. So there is the gradient for our line. Okay, it's not enough. We don't even have 1 point on our line to go substitute in so that we can get the missing c value, our missing y-intercept over there. Okay, but thank goodness we can use our purple line again. Do you remember we said that it's important that they share the same x-intercept? So if we can find the x-intercept of the purple line, we have a point on our orange line. Okay, this is a tough one. So let's go finish and find the equation of our line g of x. So we already for g of x, let me just specify there that I'm working with g of x. And so far we know that y is equal to 3 over 2x. But we've got the y-intercept. I actually didn't see that. We've got the y-intercept of g of x, so we do have its equation because that will just be plus 3, right? Okay, perfect. We've got the equation of g of x. What are we trying to find again? We are trying to find the x-intercept of g of x. Why? We are making y 0, but why are we doing that? Well, if we have the x-intercept of that, then it means that we also have a point on our line that we're looking for. So let's go ahead and do that. We make our y 0, and then we're going to solve for x. This is like so many skills coming together now that you've learned in this section, grade 9. What am I doing? Oh yeah, I'm finding for x. And then let's do that. 3 over 2x. Now, how you solve it from there is completely up to you. There's not just one way of doing it. What I'm going to do is I'm going to divide the right-hand side by 3 over 2 because it's being multiplied by the x. So if I divide by that same thing, it's just going to cancel. And then I've got x left, but then I also have to do the same on the other side. So I need to take the -3 and I need to divide that by 3 over 2 as well. What would that be? I've got a feeling that it would be -2, but let's just quickly check. I don't have my calculator close, so let's just quickly do a calculation. It's -3, let's just put it over 1, that is being divided by 3 over 2. And that would be times by 2 over 3. Yeah, that works. How did I think about it initially? I just said, well, it is 3 that is being divided by 1.5. How many times can 1.5 go into 3? Well, 1.5 can go into 3 twice. Okay, we just found the x-intercept, where our y is 0, our x is -2. And there we just found that point. Thank goodness we now have a point on our orange line that we can go plug in. So in our orange line, now this side we are dealing with f of x. So far we've got that our gradient would be -2 over 3x. We found it over there, right? Using the perpendicular line idea. And we don't know what our y-intercept will be. But we've got a point that we can substitute that is on our line. On our line, we've got the point -2 and 0. Let's go plug that in. So into the place of y is 0. Into the place of x is -2, and then plus c. There is the missing variable that we are trying to find. Now we just need to solve this equation. So this would be 0 is equal to -2 over 3 that is being multiplied by -2 over 1. I'm just making both of them fractions. You could just put it straight onto your calculator. And that would give me a positive 4 over 3. Am I right? Yeah, 4 over 3 plus c. And then to get my c by itself, I'm just doing that. And finally, we found the equation of our line f of x. So f of x will have the equation of -2 over 3 x and then minus 4 over 3 for our y-intercept. So that point over there is -4 over 3. I think this is a pretty tough question. So when you see something like this, grade 9, it might have quite a high mark allocation because there's multiple steps. You have to find a gradient, and then you have to substitute that, and then you have to use perpendicular lines to do that, and then you need to find this x-intercept, and then you need to plug it in there. So maybe... Cheapers. Maybe it would have had some leading questions, I'm not sure. But when we see a high mark allocation like this, we freak out and we think it's a really difficult sum. Not necessarily. We have all this knowledge. We must just bring it together, put it together, and all the multiple steps then gets you lots of marks.